So a random sample of 400 adults 20 to 34 years old found that 272 of them have at least one child. Obtain a point estimate for the proportion of adults 20 to 34 years old with at least one child. Construct a 95% confidence interval for the proportion of adults 20 to 34 years old with at least one child. What sample size would be needed to determine the proportion of adults 20 to 34 years old with at least one child to be within 3% with 95% confidence? So we have a confidence interval for the proportion. Okay, it says do a confidence interval for the proportion. So that's what we're dealing with. A point estimate is a sample estimate. So our sample estimate is 272 over 400. That is our p hat. So 272 divided by 400 is 0.68. Any questions? So if you're ever asked for a point estimate, it's just a sample estimate. So now we want to do a 95% confidence interval for the proportion. And we have 272 out of 400. And then the second part is a sample size needed for the proportion of adults with at least one child to be within 3% and 95% confidence. So we'll go to StatCrunch. All right. Get rid of this stuff. Okay. So we're doing, if you look at the formula sheet, if you want to do a confidence interval for the proportion, it's stat, proportion, stats. One sample with summary in this case, because we don't have data. So our number of successes was 272, and our observations was 400. And we want a 95% confidence interval and compute. So our confidence interval would be 0.634 and 0.726. Any questions? Notice it also calculates p hat for you. So if you want to use StatCrunch to calculate p hat, it'll do that for you too.
Can you run that again? Because I was taking notes.
Yep. Also remember that formula sheet. It's right on the formula sheet.
Okay.
So if you, it's on the second side, or the first side is the confidence interval, the second side is the sample size. So the first side at the bottom for proportion, it's stat, proportion, stats. One sample with summary. And then it's X over N, so 272 over 400 and confidence interval. Compute. Okay, so the second part asks us, I'll just leave that up there. The second part asks us to find the sample size for a confidence interval. So it's proportion stats again, one sample, and width sample size. I'll pull that over here. Our confidence level is 95%. Our target proportion, they didn't say anything about a prior estimate. Remember the whole prior estimate thing? So this right here is where a prior estimate would go, but they didn't give one. So don't worry about a prior estimate, just leave it alone. Okay, so leave it at 0.5 if there's no prior estimate. Otherwise, the prior estimate goes there. The width we wanted within 3%, which is 0.03. So our width, we double that to be 0.06 or 6%. So that goes here. And we compute and get 1,068. Any questions?
No.
Okay.
How did you get how did you get the StatCrunch window for the sample size?
For the sample size?
Yeah,
Sure.
I think I missed that. I'm
Okay.
writing too many notes, I think.
Okay. I am recording and I am doing all the screenshots, but so if you miss anything, you can go look. What am I doing? Oh, just want to close this. So it's stat proportion stats, one sample, and then with sample size.
Okay, proportion, one sample. Okay, I remember that now.
The width sample size.
Mm-hmm.
Again, it's on that formula sheet. When you pull it out, Kate, you'll go, oh, yeah.
I'm going to be like, oh my God, why didn't I print this out like weeks ago?
Yeah. Okay, so that gets us through 15 points of the 25 points. So you're already 2/3 done. All right, next. It doesn't quite fit. So in 2018, 54% of people had seen a movie using pay-per-view. A researcher believes that the number of people who have seen a movie using pay-per-view has increased. Set up a hypothesis test at the alpha equals 0.05 level. So this is the time to have those sheets for the hypothesis test. So remember, there was one for the proportion and one for the mean. You know what I'm talking about?
Mm-hmm.
That went through step by step by step by step. So the first thing it says is figure out first, is it a hypothesis test for the proportion or is a hypothesis test for the mean? We do not see the word mean anywhere, and we see a percent. So that tells us it's a proportion. So we have a proportion. And we have P equals 0.54. Okay. What are the null and alternative hypotheses? The null hypothesis is that P is still 0.54. And the alternative is P has increased, so it's greater than 0.54. Any questions? There is no dumb question, so ask them if you have them. Now it tells you the researcher polls 1,000 people. There's my N, and finds 562. That's the percent who say yes. And we need to go on and use StatCrunch. So we have I'm going to save that, and we'll go to StatCrunch. And it's stat and proportion stat, one sample with summary. Number of successes, 562. Number of observations, 1,000. Now we put in our hypothesis. P was 0.54, and we wanted to show that P is greater than 0.54. Any questions? So now I'll compute. I get a test statistic is a z-stat, 1.40 when I round it, and my p-value is 0.08. So when I go back, my test statistic z equals 1.40. My p-value is 0.08. Do I reject the null hypothesis? No, because 0.08 is bigger than 0.05, which is my alpha. And my conclusion is that I can't make a conclusion. I can't say that things have increased. So we don't have sufficient evidence. To support the claim that the proportion of people who have seen a movie using pay-per-view has increased. So that would be another 5 points, which means we've done 20 out of 25 points. Okay. We all set?
Chapter 11, right? Or 12?
This is chapter 10. Okay. So there's one question left.